helping you with Acorn and RISC OS computing.
That's about it, really. So tonight's speaker is Alan Adams. I won't tell you what he's going to talk about because he'll tell you himself. So could you mute everyone, please, Ruth, and then Alan can unmute himself.
I shall do that immediately.
Immédiatement. So off you go, Alan.
Got there. Okay, can you hear me? Somebody wave.
Yes, thank you.
Excellent. And can you see my shared screen?
Certainly can. We can, thank you.
Okay, there's going to be a lot of screen sharing, but it won't always be the PowerPoint. So in between, while I'm sharing, I can't see the chat. As I switch between shares, I can see the chat. So if there's something there, I might pick up on it. If you see something coming up in the chat that you think I ought to deal with straight away, then perhaps somebody could interrupt me.
Yep, will do.
It goes back about 40 years ago, by which time I've been participating in Canoe Slalom for about 10 years. And our club got invited to run a slalom at a local site, so we said yes. And I was down at another site, Old Windsor, in fact. This is Canoe Slalom, by the way, for those who don't know. And so, if you haven't seen this, it's been on the Olympic television recently. It's a slightly higher standard than we're running. But the idea is that you could paddle between these pairs of poles without touching them, and you get down the course as fast as possible. So the scoring is the time, plus a penalty for each time you touch a gate, and a bigger penalty if you miss one out or take them out of order. So there's quite frequently new scoring coming in. So Windsor Canoe Club are using Microsoft Basic, and they gave me a copy of this program. So I adapted this to run on the BBC Micro in 1982. And the first mistake was I tried to capture all the gate penalties. There's one boat down the course every minute. There's about 20 gates on the course, so every 3 seconds there's a new penalty. And somebody on the phone to the judges was trying to put all of those into one computer program on one screen. Not surprisingly, the operator and the BBC couldn't keep up with it. So the Mark II, I stopped recording the individual gate penalties, and all we recorded was the time and the total of the penalties. The disk buffer is 256 bytes, so I set the record to be 64, sorted the records into order, which meant you could do 4 competitors before it did a disk read or a disk write. This helped with the performance. It also checked the arithmetic, not of the total of the penalties, but the final score is the sum of the penalties and the time, and it's not unusual in the heat of the moment for the clerk to add them up wrongly. Favourite one is to put the competitor's bib number down as the score. So it checked for that, and that could keep up. We used the Watford DFS when we went over to the disk filing system. That has some advantages. It's because we bought the computers from Watford Electronics, and that because I was working for Plessey at the time, and Plessey had an employee deal where they'd give us an interest-free loan and bulk buy the computers. So somebody took a van down to Watford Electronics and came back with, I think, about 80 in the first order, BBC Bs. Watford DFS, it had 5 disk buffers. You could have 5 files open at a time, but it always used them from the bottom. So if you only ever had 2 files open, you only used 2 of the buffers. So you could move page downwards and overwrite the other 3 buffers to gain a bit of extra memory, which those of you who programmed BBC Micros will remember was absolutely critical. The display ran in mode 7. That way it only used the K of memory. There are a series of programs involved. They use libraries for common code, and the libraries are installed, which means they're permanently in memory. The data file is held open instead of closing it between operations, because on the floppy disk filing system, opening and closing files was quite slow. Next generation, we added a second computer to display the results of the current class to the competitors. So that computer ran diskless, and we fed the computer to it, fed the program to it over a serial link, used spool on the main computer and a couple of StarFX commands on the receiving computer. The last line of the command said run. The program ran on the other end, assembled the assembler code, and then sat there listening for things, updates coming down the link. That display ran in a 4-color mode. I can't remember which mode it was, but again, it was to keep the memory usage down, because the results for a whole class, which could be 200 competitors, all had to be held in memory. Moved on into RISC OS. The main computer was now an A3000. Ran the same program under the 65M, because it has still got the BBC assembler in it. It worked. And the next year, I took the assembler out and replaced it with an equivalent in BASIC, and the whole thing ran a lot faster. At this stage, I was still using a BBC Micro for the display. The next year, I upgraded the main computer to an A5000 with a hard drive, a massive 80 megabytes. Remember those? And the A3000 became the display computer. That had a floppy disk on, so the storage there was local as well. So this is what control looked like. So this thing in the middle is the timer, hardware timer. Clark on the left has got the start list in front of her. As a competitor comes up to the start, she finds their card, sets the timer ready to receive a time for that competitor, and passes the card on to the first judge's clerk, who is over here. When the judge who's on the start presses the button on his phone, the clock starts. The clerks here then phone the judges that they're talking to, write the scores on the card, pass the card to the next judge, pass them to the finisher. A competitor may have finished by this stage. The clock is still holding the time, but before the clock gets reallocated by the starter, the finisher writes the score down. Then the card arrives, copy the score onto the card, add up the penalties, add it to the time, and pass it to the person on this computer, who adds it to the computer. Fairly labour intensive. And we did that for many years. And I wanted to be able to have more than one station able to access the data. This meant using something different from a serial link. It meant that while the scoring was going on, I could be working on the next day's database, or I could be printing results for classes as they finish, or just after they finish, so that people can see what the final class result was. And I can also start working on the prize giving list. Version 1 used ShareFS. Always open the files from write, so only one program on the network could ever have the file open. So it did an open, modify, close. If something else tried to open and got refused, then it waited, retried about every couple of seconds. And it did work, but it was a bit clunky and it certainly wouldn't have scaled. So I started looking for a database on RISC OS which had RISC OS clients. And I couldn't find one. Data Power has a client on its host machine, but as far as I know, you can't have the host on a different machine sharing the database. I could have done it with MySQL, but there wasn't a current RISC OS client. If I was doing it now, what I would do is use data power with a program on the data power computer, talking over its API to data power and providing network connectivity to the other programs. Instead, got TCP/IP library from WROCC. He ported his C1 to BASIC. I wrote a server process, so only the server opens the files, and then a messaging system between the client programs and the server. The clients can all run on one computer, and I'll show you that happening later. But equally, they can run anywhere on the network. This is one of the messages. So when a client starts up, it says, what races are we running today? It says get races is the command. And you get this back. It says race info, how many days there are, how many races there are, and then details of each race. That message is about 2K bytes. Not easy to handle in BASIC. Made a few decisions. Use TCP/IP, TCP rather than UDP as the transport. UDP, the message goes through in one chunk or not at all, but you can't guarantee that it's gone through. TCP, the message is guaranteed to arrive, but it might arrive in pieces. And it does on a big message. So you need to reassemble the message. So messages can be over 255 bytes, as we saw before, but you can't just load the message into a basic string. So we use ring buffers, written in BASIC, which is interesting. I don't know if you're all aware of a ring buffer. Basically, it's a buffer that you put data in until you reach the end of the buffer. And when you get to the end, you start again at the beginning. I'll show you a little bit more of that in a minute. All the buffer handling is in a common library. So all the programs share that code, which means if I change things, I only need to change one place. So there's a routine that scans the buffer to see whether the whole message has been received yet. If not, it leaves it in the buffer and waits for the rest. And there's another routine which starts at the beginning of the buffer and reads until either a message separator or a message end character. If I go back to this, the message separator is the tilde character. The message end is the hash character. There's a little bit of filtering goes on in some parts of the system to make sure those characters never appear in the message itself. So all the pieces between those separators will fit in basic buffers, basic strings. So it reads it into a basic string, and then there's loads of case statements that decide what to do after that. Those reading routines need to handle the buffer end and the wraparound cases, and that's where it gets interesting. So this is what the ring buffer in the server might look like over time. Send a get races command, data end is there. Server processes it, moves data start up to data end, so it's empty. Then a ping comes in, I'll talk about those later. Data end moves up, it processes the ping, moves data start up. Buffer is now empty, but the point where it's going to load data is always data start. Then it gets a long message, put comp, which has a whole lot of parameters it needs, which gets you nearly up to the end of the buffer. Processes that, data start is now sitting here. You then get a get score command. Well, the get score continues at the beginning of the buffer, and it goes on until you find a hash character. And you'll see that what's in the buffer beyond the hash characters, the remains of the previous messages. That proved to be important. So libraries contain the null polling code, and later on poll word non-zero code. I'll talk about that later on. So that reads the beginning of the message, which is the command, and then it looks for a routine that will process that command. So the put comp command is put comp _ exec to proc. The library's got empty routines for all of those, So if an application doesn't want to handle it, the empty routine simply removes the whole message. There were a few bugs in this. It took a while to nail them. And the last one I nailed last year, many years, at least 8 years after I'd first set the system up. What was left in the buffer immediately after the hash was another hash character. And it treated that as an empty message. Said, oh, I've got a message. I don't recognize it. Nobody's handling it. I'll leave it in the buffer. So it read it again and again and again and again. And it never got out of that loop. It was caused by reading one character too many. Off by one error is particularly tricky. So to start up the connection from a client to a server, the client sends a broadcast. The clients know the port number that the server will be listening on. Basically, it says, who's the server? And I am called this. The server sends a message back saying, I'm here. I'm listening on this address and this port. Because the listen port is a different number from the broadcast port. I'm still not sure whether that's essential, but it's the way I wrote it and it works. The server checks the name because some of the clients have their own specific messages. So some occasions, the server will send a message just to one client, not the one that's received anything from, but the one that needs to know something's changed. Then the client requests the event details. So it sends a get event, and then it sends get races, which is the one I showed you a minute or two ago. And then it does things in response to what the user's doing. So the server receives a message from a client. It'll either request information, in which case the server sends it, or it will be sending information, in which case the server acknowledges it. And the clients always wait for the expected response. That's generally okay. If the server encounters an error, normally it will send the error message back to the client. There are some I haven't tracked because I haven't encountered them, but generally it's sent back to the client. So the client displays it to the person using the client, or it handles it. It's quite possible there's nobody watching the screen on the server computer. Now, if, for example, somebody is editing the start list, that's the list of paddlers, and changes a competitor's bib number, which is the number that they show that they compete under, this happens quite often, then the clients that have got that list of bibs available to the user has to update that list. So it will send out a comp change message to all clients. So that will come in when the client isn't expecting a message. Now, if the client's waiting for a response for its own message, and it gets one it's not expecting, it has to deal with that somehow. It doesn't try and process it immediately. It moves it into a different buffer, waits for the one it's due to respond to, responds to it, and then goes back and processes the deferred messages. Keeps things cleaner. The most likely deferred message is a ping, and I'll come to those later. So these are the unsolicited messages. For each of these, there's a handler routine. As I said, the library contains empty ones. So if the client doesn't want to react to a comp change, it doesn't include a routine. The way BASIC works, it looks in the program first and then the library for a program name. So if they both exist, it will find the one in the program. And if they don't both exist, it will find the one in the library. So by default, it uses the empty one. The empty one removes the message from the buffer, just discards it. So as I say, comp change is one that the users may well need to see if the bib number changes, or a paddler is deleted, or a paddler is added. Various other things cause comp change to happen as well. And the clients don't respond necessarily to every possible comp change. Network performance wasn't bad. I left the messages as plain text because it makes the debugging easier. I could have condensed them, made them shorter, which might have produced a slight improvement. But the transit time of the message on the network isn't the issue. It's the time to get a response to the message. So the code up until a couple of years ago was using WIMP poll idle to read the messages. I couldn't use it with zero waiting time, because if the client and server were on the same computer, the server never got a look in. So I had to have 1 centisecond on each of them. It means on average, half a centisecond to receive a message, and then half a centisecond for the other party to receive the message. When I print the results, for 200 competitors, they could be 1,000 messages. Not quick. And talking to Rule at the show, somebody mentioned Socket Watch. The Socket Watch module sits on the network, and as soon as anything comes in, it changes the poll word. When you're writing WIMP polling code, one of your responses is poll return 13, which is the poll word is no longer 0, and it's immediate. It doesn't wait for the 1 centisecond. I managed to use the same response code for both return 0, which is null, and return 13. I discovered in the process that WebJames also uses Socket Watch, because I've started up WebJames in the later versions of the software. When I shut down the clients, they tried to shut down Socket Watch, and it was refusing to shut down if I hadn't shut down WebJames first. So that's how I discovered it. Database is a set of flat files. And initially it was one file for one paddler, one file for each race on each day. Meant on Saturday night, most of the entries were also entering Sunday. So at that point, I copied the Saturday database to Sunday, stripped out the scores, went through and removed the people who hadn't entered Sunday and added the people who'd only entered Sunday. And about 8 o'clock in the evening, finally got to eat. So I changed the database so that the Saturday and Sunday data could be common. So I've got a header for each race, for each paddler, which contains things like their name, their bib number, and which days they have entered. And then in the day part of the race, it contains the score for each paddler. That's an oversimplification. I'll show you a bit more about that later. So at the moment, the K1 Men's Division 2 race has the information for each paddler on Saturday and Sunday. It doesn't have any information for that paddler if they've entered a different class. The C1 Men's Division 2 would have that information for the same paddler. A bib number's different in a different class. That's one reason for keeping them apart. So at this point, I'm going to switch what I'm sharing. Nothing in the chat at the moment. And share. Lost it. No, not that one. It keeps shuffling these screens and it doesn't show all of them necessarily. That's it, yeah. Scrolled off the bottom. So this file, I keep updated with exactly what the database contains in every byte. So the race header file, there's a version to start with. If I extend this file because I need to put more information in it, I'll up the version number. The reading code will look at the version number. If it's a new version, it will read the new records. If it's an old version, it will read the old records. When it writes, it will write the new version. So that's how I update an existing database. Normally, I don't have to. But for test purposes, it's very useful to have the previous year's data. So I've got the title of the race. I've got how all the scoring system works, which is unbelievably complicated. I think there's 17 different scoring rules, depending on what event, age group, and class the race is. And these are mainly due to creating a points system, which is used for creating the end of year results across the whole of slalom for Britain, called the ranking list. There's flags that define what sort of race it is, so what division it is. If it's a Division 2 race, then all the paddlers are Division 2. If it's an officials race, they could be any division, so you have to ask for it. Similarly for boats, similarly for gender in some cases, a mixed race. Team event, you would ask for all sorts of stuff. What resolution you're timing to, 1 second, 10th or 100th. You get a day header file. This is defining the race itself for each day. So how many competitors there were, how many of them started the race, whether you're currently looking at their first or second run, what the minimum promotion score is if it's a class where people get promoted. That's used for cross-referencing other classes. So, fair stuff. Skip the gate map. Race day gates. Bunch of other stuff. All of this is related to day gates. Later on, in the last couple of years, we've started putting the gate penalties in again because we can now use multiple stations to do it. We should be okay on speed. So there's an extra section, which is the gate penalties. So for each gate, there is a penalty. There's also a flag that says which clerks have finished updating their records. I'll show you how that works. Well, mention how that works later. I said earlier I'd oversimplified the database. You can see now just how much I'd oversimplified the database. Wait for a few things to disappear. So as a result of doing this, we can now have more than one display screen. Remember, the original system used the display screen fed over a serial link. We now typically run 4. So one of the client programs is called Display Manager. Runs on one computer. Multiple computers run the scrolling display. The Display Manager manages connections with those. The displays don't connect to the server. So the Display Manager knows that number 1 is displaying Division 2 MEM. This is what the displays look like. Didn't mean to skip on at that point, but it's quite appropriate. So this is displaying quite a small class. This is displaying one of the big classes. And these displays scroll slowly, a bit like the old advertising hoardings that were motor-driven. I'll go back. So Display Manager knows what each of the display computers needs to know about the competitors it's displaying. So Division 1 Men's 2, it's only one class. If it's displaying juniors, it's looking for all the competitors from all the classes who match an age category. So when a paddler record changes, the Display Manager is told if one of its clients, one or more of its clients, is interested in that record, then it will ask the server for all the details and will pass those details to each client that needs to know. This reduces the impact on the server quite considerably. So you get a queue of competitors excitedly talking about their scores as they're going live, almost live, on those screens. They appear on the screen as soon as the 5th person in control has taken the card and entered it onto the computer. So it's within a few minutes. By the time they've got off the water and walked up there, it's normally on display. So this is a bit I've just explained. The display manager receives the change flag, checks to see. It can also be used to tell the display computer to print what's on its display. You can change which class is there from the display manager. And you can shut down or restart a display computer because they may have no keyboard or mouse. So we'll show you that one running. If I can find it. Again, Zoom reorganizes the windows. Each time you go into it, the window you used last time is in a different place when you're trying to pick a window. Okay, so scrolling display on the top left, bottom right is the manager. So the menu on the manager allows you to pick, let's say, Division 2K1 women, and they appear on the screen. You can pick one of those classes like Superclass. It's every competitor in every class. Takes a bit longer to appear because it's got to get every record for every class from the server. That comes up. Then if one of these scores is updated, this screen will update. Down at the bottom, it will show the record that's just been updated because when it's scrolling, the most recent one may have scrolled off the screen. The top three are locked in position, the rest are on a pane. So you always see the top three and then the rest scroll. So this starts at number 4, but it might equally start at number 11 if you've got 30 or 40 competitors showing, which typically we will have. You have the additional options. Which I can shut down or reboot this computer. It's running headless. At the end of the day, I'll normally shut it down. Sometimes it's misbehaving and I can reboot it from here, provided the client program is listening. If the client program's listening, nothing happens. Isn't listening, rather, nothing happens. So we'll shut that one down. I've done with it. I was hoping to remember where it had been. Some programs are restricted in where they can run, not more than one copy on a computer. So that scans the task list for the matching name, brings the existing copy to the front and quits the new one. So if you try and run start list and you're already running start list, the old copy pops to the front instead of the new one running. That way you don't get a conflict that two people are trying to update the same record on the same computer, which would confuse the server. They can do it on different computers. And all that happens is the one that updates last gets to win. Some programs can exist only once on the network. The display manager is one of those. You can't have two display managers. So it's sent to broadcast out on the network. I've got the thumbnails in my way. Well, I can get rid of them. Sorry, this is annoying me. It's sent to broadcast. If it receives the broadcast with its own name in, it replies. And the new copy decides what to do. Well, between them, they decide what to do. Some programs are set so that the new one quits. The display manager is set so that the existing copy quits and the new one takes over. So you can move the display manager from one computer to another. When the clients connect to it, they tell the display manager which class they're displaying. It then continues to update them. That took a bit of writing, but it works. Now, until recently, entries were received on these entry cards. You'll see there's quite a lot of information on the top half, all of which had to get put, the key parts of which had to get put into the start list. Surname, club, date of birth, later year of birth, their national governing body membership number, what race they were, what bib number they are, age category. This is what race. That's the absolute minimum. And for years, that's what we used. The back of the card contains the score. So all the gate penalties are written down here for the first run. The time is written here. Total of penalties, total of the lot. Same for the second run. It's this side of the card that's used for scoring. So that gets passed around control, ends up at the display computer, or the main computer, and is entered onto the computer for printing. Some years ago, we decided we'd adopt the new system that the BCU had just introduced, going cardless. So instead of receiving entry cards, we took entries online, wrote a system to do it. What was happening was we'd get maybe 40 or 50 entries in the post, and another 40 or 50 would turn up on Saturday morning with their cards, and we'd be frantically typing them in. It usually resulted in the race starting late. So we wanted to get around that. So we've introduced an online entry system, took the money on PayPal, and we got it down to about 10 entries on Saturday morning instead of 50 or more. It was written using PHP and CSS, tested on NetSurf. If it works on that, it'll work on anything, was my principle. It emails the entries in, doesn't store anything on the server. It's all in the email. Then an import program processes the emails. All well and good. Up to now, the system at the end of the event was these cards get posted to the ranking list compiler, who uses them to put the information into the national ranking lists. And they needed the postal address and some of the other information. So we had to have a way of capturing that. So the online system captured all of this. And then at the end of the event, we printed the cards with the score printed on, which got over also a lot of issues of legibility. As the users typed in their own information, we transferred the scores, and the whole lot was printed rather than handwritten. That improved things quite a lot. And the Slalom Committee set up their own system after lots of people had said, that's a good system Northampton have got, why aren't we using it? About this time, GDPR came in, and they realised they were collecting a lot of information that they probably shouldn't. So they no longer collected date of birth, only year of birth, which works because the age categories for slalom are based on your age on the 1st of January. So you only need the year. They no longer collect the address. The online system collects the email address, but it doesn't send it to us. There's a system, if we need to email through the online system to all the competitors. So we don't need the email address. So it cut down considerably the amount of information that we're importing. The importer was modified. It will actually read both formats, and there's a use for that. So traditionally, we use the entry cards. Clerks are on the phone, as I showed you earlier. Cards are passed round. The summaries enter the computer, typically 5 people. There's the 5 people. Over here are the 4 display computers, which the competitors can see from the outside. Cardless, I must stop clicking on those screens. Now, the flow of information that the judges request is driven by the cards, so that the judge's clerk has a stack of cards in front, which have been passed to them by the starter. Because they've got a card, they know there's a competitor down the course, so they know they need to ask for the score. So I had to replicate that. So now the start clerk tells the computer that the paddler has started a run. This causes that competitor's record to appear on each of the clerks. So if we look at the connections of the computers, you've got the start and finish clerk, these two, and you've got the two clerks talking to the judges. So as the starter says, number 10 has started, number 10 appears on these two screens and appears on the finisher screen. So the clerk will then click on number 10, say to the judge, have you got the scores for competitor 10? And we'll transcribe them into the program. Same with clerk B, and the same with the finisher. Finisher will simply note that the clock has stopped, which is stopped by the person on the riverbank pressing a button on their phone, and will transfer the number straight into the computer. So you no longer need anybody to put the scores onto the computer. They're already there. I've shown 4 people, but I think we will be able to operate with these 2 being done by 1 person. So these are the computers that are used for the judges, clerks, and the starter and finisher. 7-inch reversing camera screens and keypads. They don't need more than that, and it cuts down the amount of table space they need to use. The box contains 4 Raspberry Pis, power supplies, power supply for the monitors, which are all 12 volt, and the network switch. So it has 1 network cable and 1 power cable coming to it, and that's it. All the other cables are stored in the box when it's not in use. The keypads and mice go in as well. Just fits with a squeeze. So the clerks see the list of competitors that they need to get results from. The oldest one's at the top. The oldest one is normally the one that they need to fill in first. But they have an option to pick a later one. Sometimes paddlers overtake, so they don't always finish in the order they start. Sometimes a paddler will capsize and not finish at all. That gets flagged up by the clerks as well. So typically 4 people, but could be 3. So I'll share yet another screen. So as I said, these normally run on different computers, but they can all run on the same one. So these are all running on my ARMX6. This is the starter screen. So starter will click on Theo and start Theo. Immediately pops up on the other 3 screens. A bit later, it'll start Andrew. Andrew pops up. We've had an official. Now, the officials are judging the event, so they aren't always available to do their run at a specified time. So an official's come along and said, I want to do my run now. And this bit's deciding it's not going to work. Most it is, it's popped up over here. So at this point, you get the chance to add a paddler. So you select the official's event. You select the bib. It's number 400. I've fixed that error, but not on this copy. He's going to do his second run. Add him to the waiting list. Right, he's now ready to start. Typically, that will happen when he goes up to the starter on the bank and says, I want to do my run. The starter says, OK, get in your boat. We'll run you at the end of this class, or we'll run you when there's a gap. So he comes up to the starter and starts the official. It should eventually appear on this screen as well. I'll have to see if I can replicate that one later. So the clerk will see that Theo has started. Say, what paddler? Judge will say, I've got a 2 on gate 3. 2 on gate 3. 50 on gate 6. I've left some debugging code in. And all the rest were clear. Save the score. I'm going to do some work on this. That should not have disappeared. you notice you can select the judges. If you select Judge A, it only offers the scores for Judge A. Judge A is doing gates 1 to 7. If instead you select Judge B, it only offers the scores for gates 8 to 12. So it's designed to prevent the judges making mistakes. Sometimes the judges want to do this. I'm going to ring Judge A and they'll get 3 or 4 scores off Judge A. Then I'm going to ring Judge B. If the event's running smoothly, it's often quicker just to select the paddler. Okay, Judge A can have your scores. Yep. Judge B can have your scores. I've definitely got to do some work on this because that's put the wrong gates up. My problem, not yours. This does the same thing. Eventually, the finisher will transcribe the time off the timer and save it. Paddler disappears from the finish. That's cardless with the British Canoeing supplied timer, the one where you've still got to transcribe times. If we're using the cardless, one of the requirements is that the paddlers are able to see what their complete run score is, including all of the gate penalties. When we were using cards, the cards got put onto a card frame, which displayed them. It's about 8 foot by 6 space that could store an enormous number of cards. So they could look along, find their bib number, see what the penalties were. And if they think their score has been done wrong, then they can put in a protest. We don't have that without the cards. So what we do instead is we have a print monitor. And whenever a complete score is saved, the print monitor makes a note of it, adds the paddler to the queue. When it's got 6 entries in the queue, it prints an A4 landscape page with the 6 scores horizontally. The reason we do it that way is that the card frame height is the width of an A4 page, so the landscape pages fit in the card frame, which is quite handy because one of our fallback approaches is that we will, if we can't get the timing system to work, and last time we tried to do the cardless system, it didn't. I'd left some debugging code in the wrong place. We print the cards and then we switch over to using cards. And we did that on the Saturday morning of the event. It took about half an hour, which is mainly the time to print and slice up A4 sheets with 3 cards on each. So for the timing, British Canoeing supply a timer and the phones to events from Division 3 upwards. They don't supply it for Division 4. But we run a Division 4, so we wanted a timing solution. We've been using stopwatches, which is a bit clunky. The Division 4 events typically only have 20 or 30 entries, so it's not a big deal. But we want to run bigger events. We're planning to run one for the district scouts, which will probably get a much bigger entry, so we need something that will run quicker. So we developed a Raspberry Pi timing solution. The initial thought was that one computer would be recording start times and a different computer would be recording finish times. They use the store time of day, just like the stopwatches do, and then you work out the difference. The problem is you can't synchronize them that accurately. NTP only works to about half a second accuracy. So the BCU timing system, the clerks press a button on the headset, it interrupts the current that's running the headset. That break in current is detected and starts or stops one of the clocks, which is simply digital counters. So I've decided, copied the electronics, I've got the circuit diagrams for it, copied the electronics, and arrange the pulses to feed into a Raspberry Pi on the GPIO pins. That way the headsets are compatible. They also built some compatible headsets. So we can run the Division 4 on entirely our own hardware, and we can use some of that hardware for the Division 2 3s. That's the timing unit. These weird-looking plugs have one pin and one socket, so you can't plug them in the wrong way around, and all the phone wires use the same plugs and sockets. So the DC supply goes to the phone, arrives the right way around. The Raspberry Pi is powered up the GPIO cable from a 5-volt supply inside the box. That's the inside of the box. This ribbon cable plugs into the socket here when the box is closed, but it's a short ribbon cable, so you have to unplug it to get things open. So we're using one Raspberry Pi. We don't need to synchronize the clocks. The GPIO module software doesn't allow BASIC to access the interrupt routine, even through assembler. You'd have to write something which bypassed the GPIO module. What it does do is allow the pulse to be stored and a status register read, which says there has been a pulse. So I write some code that sits on the ticker vector, which runs every 100th of a second, and it polls the register. If either or both pins change, it records the counter value. It also increments the counter. So it's got a 32-bit counter of 100ths of a second, and that value is what's stored. It also stores a flag to say whether it was a start or a finish pulse. This means if it's sent some start pulses to the server, or start timestamps rather, then you have to restart the timing computer. When the paddler's still on the water, they get a valid stop time. Because when you start this program, it stores the machine's internal clock, the 5-byte clock. And when it sends a timestamp to the computer, it sends the 5-byte initiating clock and the counter, which is an offset from that, and the flag byte. You need to do some 5-byte unsigned arithmetic to work out the difference between the two timestamps. That proved to be interesting. So when a pulse is detected, it also sets the poll word to non-zero. So the software, as soon as BASIC gets control, returns to the program. The poll word code moves those stored values in memory while the interrupts are disabled. So it disables interrupts, moves the values somewhere else, clears that area of memory, and re-enables interrupts. That way, if a new time comes in, it doesn't mess up the stack. The BASIC program then reads those values out of memory and sends them to the database server. So the two-stage process protects you against an interrupt coming in while BASIC's trying to do something. Because there's a storage of those values, it doesn't matter whether the server is busy at the time the value comes in. It will get dealt with the next time the server's available. It also eliminates any delays on the actual network. I don't plan to use a wireless network, but that's one case where you might get a delay. And then to handle this, there's two possible Clark programs. One of them looks like the BCU system. It can only be run by one operator, which can be a high workload. But I think because we're eliminating a lot of the manual steps of it, we can get down to one person to do that. So the control staff that was 5 people is now going to be either 4 or, with a bit of luck, 3. We are short of volunteers every year. The other type of program is designed to be run by 2 people at control. With those programs, get round another problem. The starter will line somebody up on the start line. So I've got competitor 23 for you. The start clerk will put 23 onto the clock. When the timing pulse arrives, it gets assigned to 23. 23 gets near to the finish line. The finisher looks away. 23 crosses the finish line. Then the finisher says, oh, that was number 23. The British canoeing supplied system can't cope with that, and nor can the one I mimicked. This one can. Because what it does, it stores up to 5 timestamps and allows you to allocate them retrospectively to paddlers. The main time this is going to be useful is not so much the finisher didn't see someone finishing as 2 people finished in rapid succession. It could be as little as 5 seconds apart. In that situation, the finisher doesn't have time to allocate a clock to the first one, wait for the pulse, and then allocate another clock. So the second pulse would get missed. This way, you can deal with it. So it's a more capable system, but it's more complicated for the users. And when we trialed it last year, they didn't like it much. We'll see how we go. This is the mimic of the BCU system. BCU supplied system is everything from the start buttons to the right. The list on the left is the same list that the manual system would have had. Again, you can add someone to the list, and this is a photograph, it's not live, so I can't run this. But typically, you click on Neil Underwood at the top of that list. The system would look for the first free clock, it would allocate him to channel 4, and it would turn the button on channel 4. No, it wouldn't. It would leave the channel as it is, because you're waiting for Bob Tilling to start. When Bob Tilling starts, that clock will cease to be green. You can then click on this one. This goes green. The next pulse will start this clock. Same applies on the finish. You click on the button. It makes the clock live to receive finish pulses. You can click it a second time and start or stop manually. Again, that mimics what the British canoeing system does. It's useful occasionally if there's a problem with the phone. That's the 1-man. The 2-man, again, uses 2 timing clerks, finish and start. Uses a timing monitor, which is the hardware box, which can be running one or more of these programs. The whole system is symmetrical in that respect. So you've got a start and finish clerk, 2 judges clerks, you've got 4 people in control. So the system can work multiple ways. It can work with cards. We can still work with cards. Those programs are still there. We can work without cards with the British canoeing timer. It can work without cards and the Raspberry Pi timer. And it can have multiple display screens, or it can send results over Wi-Fi, or it can print summary results, or all of them. This screen determines what happens. So you've got the timing, you've got the cardless flag. If you don't set cardless, then it uses the programs that enable you to record off cards. Timing mode manual. So at this stage, we're using the British canoeing timer. Or use the hardware modes. The hardware modes basically is how many people have you got in control and how many people have you got on the bank? Because one of the options is that you have one person on the bank, you have a circular course, the start and finish are the same line. So one person is starting and finishing from the bank. That means you need to direct the pulses either to a starter or to a finisher. You can't have them both active. And you only have one person in control. That typically is how we'd run the Division 4 event. The rest of this determines how many gates each judge is running. So Judge A is running from gate 1, Judge B is from gate 8, Judge C is from gate 13, Judge D from 16. Total of 18 gates, 2 clerks, 4 judges. We can go up to 10 judges and 5 clerks with this, never likely to. We can go up to 25, which is the maximum that British canoeing allow on the course. Normally we run 18. This year, in order to avoid crowds, we're intending to put the results available on the website. The website's run on a Raspberry Pi using WebJames. We use a wireless access point, so competitors will need to attach their phones to a local wireless hotspot. And then the website Raspberry Pi receives the score change messages and continuously updates its displays. Performance issue. Each update results in a complete class being rebuilt. So somebody might have moved his score from 6th to 3rd. So everything from 3rd down to the end of the class has to change. So it wipes the class and builds a new file. This will be hard for the server to handle because it would happen every time a competitor in that class finished, once a minute. So what it does instead, it copies the database over ShareFS when it starts up. Then when it receives a notification that a paddler's score has finished, it updates its local copy of the database and then builds the file from the local copy. So it only needs one record. ShareFS takes a few seconds. In fact, it takes long enough that I had to break it down into a series of WIMP polls, each of which copied a small part of the database. I tried this some years ago with a long-range wireless access point, and it caused trouble with the scoring network. I never did establish why. I suspect it was just the level of network traffic. It could also have been something that was being sent, because we'd have a lot of phones connected to an access point straight onto the Slalom network. So what I'm looking at is a way of buffering it. So putting something between the web server Raspberry Pi and the rest of the Raspberry Pi network. And I think the minimum protection is to bridge the network, which will allow ShareFS to still work, but the only inbound traffic acceptor will become from the Raspberry Pi that's doing the web serving. So no inbound traffic from any other address, i.e. from any of the phones. The Linksys router is one that you can load Linux onto and set up all sorts of special stuff. I'm really hoping somebody around knows how to do that. I did look into IP tables, which is what I think is the piece that's needed. And on the first look, it looked more complicated than I wanted to try and sort out from scratch myself. I'm looking for somebody who can give me a crib. Systems designed to be resilient. So if you shut down the client program and start it up again, it will catch up. The server will provide it with information of where it was once you've told it which class it's allocated to. If you restart the server, most of the clients can continue when it comes back. And some of the things it writes to disk are only done for that reason. Normally it stores them in memory, but it keeps a disk backup copy. The clients detect when the server link isn't working. They pop up a notification window with the option to cancel. Sorry, to quit the program. If you don't quit the program and the server link comes back, the window goes away and the program carries on. That is the normal operation. So they reconnect automatically. Each client sends a ping to the server every 5 seconds. The server pings it back. The server keeps a timeout on those for each client, and the clients keep a timeout for the server. So you can, for example, pull a network cable out, and within 5 seconds, the client and server will detect it. Put the cable back in, the network will come back. That took a lot of sorting out. Some of the programs are critical. The way the whole system works is that the first thing any client runs is a program called Launcher. The main purpose of the launcher is to provide a menu of the things that that computer can do. So the display computers that the competitors see, for instance, can run the rolling display. They can also run a program called Show Me, which allows them to select their own score and see the details of it. That would run with just a mouse. They aren't allowed to run anything that can alter the database. The office computer, which sits there, which is used for answering queries, can access start list. So it can tell the start list that somebody who owes money has now paid it. It can deal with somebody who didn't give us a bib number when they entered, probably because they'd only just been promoted and didn't know their bib number. We allocate them a temporary bib number. They've now got the real one. They want to run with the real bib, so we change the bib number. A number of queries like that. So they need access to the start list. So that computer has a different menu of things it can do. The scoring computers have yet another menu of lists. Now, each of those menus has the option to say this computer program should run when Launcher runs. So Launcher will automatically start that program. Well and good. The server is loaded with a list of programs that must be running. That must keep running if they have been started. So if we're using hardware timing, then the timing monitor is a critical program. If we're not running hardware timing, the server will ignore the hardware timer program. But if it's once seen it running, it will try and keep it running. So it sees the hardware timer come up on, let's say, Raspberry Pi 9, and it will flag the fact that it's running on Raspberry Pi 9. If that connection disappears, the server 5 seconds later, it gives time for an automatic reconnect of the network. If it doesn't reconnect automatically, the server tries to send a message to the launcher on that computer saying, rerun the timer monitor. If the launcher's gone, that fails. And after 2 or 3 attempts, it will stop trying to talk to the launcher. That's about a minute, because that means the computer's crashed or the cables come out. It's something it's not going to recover. But generally, it will recover them. And sometimes you want to stop it doing that. So the server's menu has an option to enable you to control whether or not that particular program is auto start. So the background result printer for cardless is one of the critical ones. The display manager is another. The web updater for Wi-Fi scores is another. And you can make any of the others critical. Last 2 seasons, we haven't been able to run events. Normal process is that each winter I will update the software, not least because the scoring rules tend to change each year. And they're hard-coded because they're too complex to do any other way. And next year, we get to test the changes. So it limits the amount of change that there's been that might go wrong. We've now had 3 years of winter changes with no testing. So cardless has only been used at a div 4. We tried to use it at a div 2.3. I said I left some debugging code in, which meant it didn't work. So we had to fall back to running cards. The timing add-on hasn't been used. This version of the web results hasn't been used. 2nd of October, we're running our major event. I found a few things tonight I'm going to have to work on between now and then. For 40 years that this has been in development, 40 years, good grief. We've had to deal with memory limits on the BBC Micro and the fact that we only have one of them with a disk controller. We've had the fun of dealing with ring buffers in TCP/IP and managing all the edge cases that occur there. You know, message ends 1 byte before the end, message ends at the end. The terminator byte is the beginning of the buffer immediately following the message. You've got 2 terminators together. I think I've found all of them. Now, timing on a high division event is supposed to be done to 100th of a second. This system is theoretically capable of that. It's only intended to be used with 10th of a second. But you've got to subtract 5-byte timestamps. They're unsigned. And if you ignore the high byte, which is the highest byte, in February 2021, you get huge negative times because it wrapped round. You have to do the calculation byte by byte. You can't do it using integers, even in assembler, because the low 4 bytes have to be treated as an unsigned word. And then the remaining one is network traffic from wireless. Some people I definitely need to thank. Dave Ruck gave me the socket lib library, which was essential. I couldn't have written the network layer or any of the stuff above the network without that. Martin Averson's reporter, I couldn't do any of the development without using that. And ARM sort is used quite extensively. That knows used a fast sorting of arrays. And Socket Watch, which originated from Dick and Hood. I'm not sure whether he's the current maintainer or if it has never been maintained. It was maybe simple enough. It never needed any changes. And I've had lots of help from the forum, particularly trying to sort out the interrupt code. And it was those requests for help that resulted in the suggestion that I do the talk. So, thank you, David. Just seen your comments on the chat. So, anything you want to ask me? Stunned silence? Baffled?
Which model Raspberry Pi do you tend to use?
The 4 originals are Bs, 2 Bs. The timing one is a 3B. I've had to replace, no, I think the original might be 1Bs. The 4 built into the aluminium box were 2Bs. I managed to blow one up recently and I've replaced it with a 3B. The timing computer is a 3B. Blowing up with a caution. I've got a little module that's designed to be an expander for the GPIO bus. And it has a ribbon cable between it and the GPIO. Neither end of that cable is keyed. On the GPIO, there are 5 0-volt pins. It connects them all together. If you rotate the connector at one end, it connects 5 volts to 4 of the GPIO pins. The Raspberry Pi doesn't survive that. GPIO, of course, is a 3.3 volt system. And I managed to rotate the cable. The keying, it turns out, is if you look on the back of the printed circuit board, pin 1 has a square pad, all the others have circular ones on both the Raspberry Pi and on the expander. But I don't remember that being in the data sheet for anything. So I wasn't all that happy about that, but they're not massively expensive. I'm still debating where to run the database server. Up to now, every time it's been on a desktop computer. Last time we ran this, I was having trouble with the ARM X6 occasionally locking up and occasionally refusing to boot up. Since I replaced the SSD with a hard drive, I've only had that happen once in about 8 months. I think it was a dying SSD. It was about 5 years old. But I'm debating buying a Raspberry Pi 4 to use as the database server. Possibly run 1 or 2 of the background processors on it as well. I've got a couple of weeks to make that decision. The Pis, incidentally, I take a copy of one of the SSDs and clone it to all the others. I've got them set up. The network address is defined as from host name, if you've seen that option in the network setup. And every one of them has a host file, all identical. So if I set its name to RPI3, its address is the RPI3 from the host file. That way, when I've done the clone, all I need to do is change the host name in network setup. And the sharing is done for a little bit of BASIC that shares it with the host name built into the share name. Just makes life easy when you're rebuilding. Anyone else?
Do other clubs have systems worked on other operating systems? How do they compare with yours?
Yes, they do. Most clubs use a system called Simply Slalom that runs on one laptop, and I think, display on a second one. It does import from the online entry system, but it doesn't have the same degree of customer friendliness that I think we have.
Yeah. You're one up on everybody else, really.
I think so, yeah.
Yeah.
Certainly were with online entries. We were doing it for 5 or 6 years before the national system decided to go ahead with it. Okay, this is a better system, much more complex. It was written by a professional programmer using professional development tools. I'm not sure. It's not Rails it runs on, but it's one of those exotic things. And obviously it's got to cope with a lot more different conditions because it's running every category of race across the country, including championship races, which have different race formats, all sorts of other things. So I'm not unhappy they've gone over to it, and we've adopted it because that's where the competitors look to see what events are available. So it's advertising for us. If we use our own system, we've got to do our own advertising. I've got a message saying, did I try Bonjour? I thought that was an Apple-only system. I'm probably wrong in that, but that's why I haven't explored it anymore. That's from Dave Fergie. See if I can see any more of that message. It's truncated.
In terms of your Wi-Fi, what are you using? Is it 2.4 gigahertz or a 5 gigahertz band, or doesn't it matter?
All we're using it for is for the competitors. What I did was buy an outdoor wireless access point because the slalom site is about 120 metres away from the river. The control site, rather, is about 120 metres away from the river. The competitors would rather get the results while they're standing by the river. So we needed one with decent range. I think it's 2.4 only. It's LB link. I've got my doubts about that because when we plugged that on, I used a better known make of access point in the early trials and it worked fine. I put that one on the network and it messed up the way the network was operating. So I'm not sure what its software is like. BL Link is obviously a very careful way of making you think it's a D-Link, which is, of course, a better brand, or a more well-known brand anyway. I've worked with D-Link a fair bit, so I tend to trust them. And interestingly, since I bought it 3 years ago, there have been no software updates for it. So that's why I want to filter it off the rest of the network. Because we're more network critical now than we were when we ran that previous one. And it's more critical now that we have the wireless system in place because we're being urged very strongly by British Canoeing to avoid crowds. The display screens do produce crowds. Okay, we could spread them out a bit. We've got 4 windows out of the room we're operating. I can put one in each window. That'll produce 4 smaller crowds. But ideally, we still do the wireless system. I'd like to put the start lists on that as well. So, because the other query people come up for is, when am I starting my run? The problem is that on the Saturday morning in particular, the start list is dynamic. Because as you get more interest, you're always running descending order of bib number. So as more bibs come in, the lower bib numbers, start times get later. And it can be sort of 10 minutes later, but between 10 o'clock on Saturday morning and midday when we start the paddling. If they're planning their warm-up time carefully, and some of these are serious enough athletes to do that, being 10 minutes later on the start upsets them. Whether it actually has any effect, I don't know, but it has a mental effect on them. They get annoyed. So we try and keep the start lists up to date. We keep printing them and posting them on the display boards. I need to find an alternative for that. But at the moment, we're trying to deal with all the remaining COVID-related issues. It's got a lot easier, but we're still going to make sure we've got a cleaning regime for the indoor toilets and changing rooms. We avoid the crowds. We don't have a big prize giving at the end. We do a prize giving at the end of each class just for the people who've won prizes. And all sorts of other things. The headsets that the judges use get shared. So we've got to put cleaning in place for those as they hand over. There's a lot to think about on top of the stress of running the event anyway. So we used to get 150 competitors. We've cut the limit this year because of COVID. With 150 competitors running at 1 a minute for 2 runs, that's 6 hours of paddling, more or less continuous, with the results coming in for 18 gates every minute. It's a lot of data.
Quite impressive what you've done. Quite impressive.
Thank you.
Yeah.
Am I a seasoned paddler, says Bernard? Yes, I started paddling 50 years ago. I stopped paddling slalom about 25 years ago, but we keep running them.
Alan, coming back to the fact that obviously you're a one-man band developer, is the source code for all this backed up, and have you made any sort of inroads into getting somebody else trained up to do coding with you? Or as ever, that's the RISC OS problem, isn't it?
It is. It's one reason why I have never offered this to any other club. I think there'll be a reluctance for other clubs to buy 7 or 8 Raspberry Pis in order to run it, and the necessary monitors and keyboards and so on. I don't think anybody from our club would be interested in taking it on. If I wasn't available, we wouldn't be running slaloms. So in that sense, it's expendable software. I have now got backups at home. October last year, I was trying to format a FAT32 external disk on the ARM-X6 and managed to format the main disk instead.
Oops.
H-form, which is what FAT32 form is based on, is not exactly user-friendly when it comes to identifying what you're dealing with. So at that point, my backups had been, I copy, when I go on holiday, huge chunks of the RISC ARM-X6 stuff onto the laptop. So I dragged all that back. It turned out I got about a 6-month gap. And one of the things I hadn't got was any of my email. Address books, archived messages. Most of it hasn't been a problem. And I've got back pretty much operational again. It wasn't far from then that I put a new hard drive in the laptop. So I bought a new laptop and transferred the hard drive from the old one. My laptop choice for the new one was limited because I wanted one that had got a hard drive bay in it. Although it's got an SSD as its primary disk, this one has a spare bay. So I took the complete disk out of the old laptop, put it in the new one, and I didn't have to copy anything. Just change a few drive letters. So that was quite useful. But now I've got a NAS sitting in a separate building with a network cable to it. that can be woken up by RISC OS and by Windows when they're due to do the backup. That's automatic now. I've got backup to the SSD inside the ARMX6, and I've got backup to this external FAT32. Once you get a backup disaster, you tend to go for belt and braces. I say it could have been a much bigger disaster.
Yeah, belt and braces is a very good policy.
Well, mine backs up to one NAS, and that NAS backs up to another NAS.
Well, this NAS has got mirrored discs. Tell me if one of the discs is going bad. It's in a different building, so if somebody breaks in and steals the computer, I've still got the data. If I get a fire in the house, it'll probably not take that building out. I think that's paranoid enough. My job before I retired from Marconi was, among other things, managing the backups on the mainframe system. So I really shouldn't have got there. But I spent 18 years in that job, and our biggest issue the entire time was that you could never get a tape drive with enough capacity to hold a disk drive. We ended up, the nearest we got was a 10-slot cartridge loader where we could get our biggest disk drive onto 4 of the cartridges and then do differential backups onto the other cartridges on a rolling cycle with auto loading. That was the last thing I wrote before I retired. That was on VMS. And we started with VMS with a 100 meg system disk. Then we bought a 400 meg data disk, and it took 4 tapes to back it up. These are 11-inch reel-to-reel tapes. And the tape drive capacity never caught up with the disk capacity. Never has. I don't think even now you can do a serious mainframe backup onto tape. And not only capacity, time as well. The most spectacular bit was a pair of 250, a big tape drives. These are the size of a freestanding fridge freezer, a big one, each. They write at 125 inches a second. They rewind at 250 inches a second. You load tapes onto both. You start the backup process. It goes to tape 1. When tape 1 finishes, that starts rewinding. It continues writing tape 2. You've just got time to put a new tape onto drive 1 for tape 3 before it wants it. And doing that, you could back up the big disk in about 20 minutes. And these tapes are loud and fast, a lot of compressed air involved, quite noisy things. But that first VAX was 1.25 megabytes. We bought an upgrade to 4 megabytes for it. That's the main memory. It cost £16,000.
A bargain.
Well, it wasn't bad at the time compared with what IBM were charging. But, you know, things have moved on a bit. And the 100 meg disk drive was, the 100 meg system disk was a 4-platter removable disk. And it was the size of a washing machine. Top loader. Yeah, things have moved since, what would that be, about 1977, 78, I think.
When's your next live event? Is it till in a couple of weeks' time or something?
4 weeks. I've got some debugging to do before then. And when I showed you the 4 screens, things weren't always coming up right. That's going to be messy. The debugging system, I've got an awful lot of code using Reporter, because all the reporter output goes to one screen. I've also got logging, where each computer can log to a file of its own in the RAM disk. That way I'll get the separate information from each computer. So for the network protocol message, what sent what to who and when, and what was the response, I use the logging, because it's easier to see that, and they're all time-stamped. And 2 system variables turn the whole thing on or off. I turn it off for the event because it does slow things down quite a bit, especially the logging, because the server does a lot of it. And I'm going to have to use that for this, because where I think, one of the problems is I think it's the run list, which the server keeps. So starter starts a competitor. That competitor is added to the run list, which is a big array in memory. The running list updates are then sent out to the clients. If a client restarts, it requests the entire running list, which is one of the ways that the resilience is handled. But normally it just gets the updates, and it looks as if one client was missing one of the updates. So I hope that's reproducible, because then it's fixable. The other problem was that when I opened Judge A, I got Judge C's gate list. And that's much more worrying, because I haven't seen anything on that problem before. And that will affect any version of cardless scoring. I'm not sure we're going to use the hardware timing, but I'm sure we want to use cardless. If only because it's the only way we can put the full competitor results over the website. Otherwise, the only way they can find out what their penalties are is to come and look at a printout. Crowds round again. COVID's making life interesting.
Certainly will be with all the COVID safety measures.
With one of my other hats on, I was very pleased this year that we managed to hold our Boys Brigade annual camp in July. We finally got the go-ahead 5 weeks before camp, so we had 6 months of planning to do in 5 weeks. Well, we had done some pre-planning. And it was one of the best camps we've had, because everybody was so enthusiastic about going. And we picked up members during COVID, because we were still running activities face-to-face when we were allowed and Zoom when we weren't. It's been something for the kids to do, so we've had a lot more interest. So next year's camp could be double the size. And that's not just a random assessment. We will have enough members moving into that age group to double the size of the camp. So we're already starting to think, what do we need more of for next year, starting with tents? Making life interesting. Hopefully, there won't be much in the way of restrictions by next year's camp.
Yeah, fingers crossed and all that.
Yeah.
Yeah. An apprentice that I was with, Mike, and I'm struggling to remember his surname, but he was on the British Canoe sort of set up, and I think he went over to the Canadian Olympics, I remember rightly. But he used to go out early morning, go down the local canal, break a bit of ice, and get some of his stuff in during the winter. So not something that you'd want to do unless you're dedicated, of course.
But he was probably doing that before COVID as well. Early morning training before work, or training in the dark after work, is not at all uncommon for the British team paddlers or aspiring British team paddlers.
Yeah, but this was in the late 70s when he was an apprentice. We were apprentices together. I think the last I heard, he got some sort of company set up down in America, going down one of the big rivers down there, doing tours and sort of helping people try out canoeing.
Yeah. Oh, good. If you remember the name, I might well remember it because the 70s is when I was active in slalom.
Yeah. I'm struggling to Mike began with it. I think it was or something. No. It'll come to me, no doubt, when this course finished.
Yeah. No, Dave Mitchell went to the States. He was Chester paddler. He set up a paddle making business in the States, and Mitchells were the paddle to have for quite a long time. Mike Mitchell was his son. He's still around. I still see his name popping up on the canoeing forums. Mike, one or two. Can't recall the surname. I could dig through the old yearbooks and have a look, but so I've still got every slalom yearbook from when I started in 1971. When there were a lot less competitors than now and a lot less events. I think there was 70 events in a year. There's now more like 200 or 300. So most weekends have got about 3 competitions on. And the season's starting sort of mid-March. We're among the last in October. I think the last one, it's first weekend in November. So, yeah. Our biggest, so we're not particularly a slalom club these days, but we reside on a very good artificial slalom course. So it seems a shame not to run an event there, but it's difficult as a result to get volunteers from the club to help run it. And it does need quite a lot of people. Fortunately, the supporters who come with the paddlers are used to doing judging. So most of the people out on the course doing the judging aren't from the club. Ideally, we have the starter and the finisher. And I've had a message today saying the guy who's done starter for us a few times is going to help. So that's one post filled. So on the bank, that's probably the hardest job to do. In control, finish is the hardest job to do. See, Doug's clock's right.
Yeah, that's unusual. I'll put some batteries back in it.
Yeah. I don't know you see what's behind me. Yeah, I can see the 4 demos were set up on those 4 Raspberry Pis in advance. So all connected over Type VNC. So I was just switching Type VNC windows when I was doing the screen sharing. In fact, if I screen share, there you are, I'm making cool. Can I share the desktop? Don't think I can. No, that's interesting. I can't share the actual desktop of the hosting computer. I can share anything that's on the desktop, but not desktop itself. Yeah, another funny one. I'll share this one again. So this is, did I show you this? This is what the original Mark I software looked like on the BBC Micro. This was actually running in 2000 on one of the Acorn machines. I'm not sure which one, but it still works. So it's all keyboard driven. This is single tasking. So if I run this and then try and connect over Type VNC, it doesn't connect. If I connect over Type VNC and run it, you're seeing the results and it stays connected. And I don't understand the difference. That's the desktop of it. So just run that. So as I said, mode 7 screen to save memory. Prune back the disk buffers to save memory. Squeeze the program into about 16K of memory that's left. You've only got 32 to start with on the BBC. The disk buffers and the screen memory come out of that, and the basic stack and a few other things. So yeah, it's tight memory. So when I do edit start list, it loads a different program. That's done with a chain command. When I go to top menu, it changed the original one back. And interestingly, I removed the last of those chain commands from the current software earlier this year. They were still in there. It's in the exit handler. If mode something or other equals, it detected if it had been run from the star basic command. If it had, it tried to chain top menu. It was never executed because this isn't run that way. But, yeah, I was quite impressed that I could actually get that screen on sharing.
I think we're all suitably impressed with what you've done, Alan.
Good. Who knows, one year I might bring it up and demonstrate the hardware. I did take it to the Birmingham show some years ago when it was a lot less developed. But this version's easier to transport because the monitors are smaller. All the computers fit into 2 toolboxes. And then there's just 3 or 4 LCD monitors in addition. Actually, more than, well, it doesn't need to be more than 4, and then he put 1 or 2 of the display screens up. So it is more portable than it was, not least because I have to carry it to and from events. And this year, the controls upstairs, because we're using a space in the building on site, using one of the conference rooms, so that we've got more room to spread people out and we can isolate ourselves from the competitors better. Not because we don't want to talk to the competitors, but COVID again. But it means everything's got to go upstairs. So yeah, we hang the gates over the course on Thursday night. We spend Friday running out the phone wires and setting up all the computers and the phone systems and testing everything. Friday night, the competitors start arriving, so we're busy allocating parking and camping spaces. Saturday morning, they keep arriving. It doesn't help. It's not easy to get to Northampton on a Friday evening by motorway. If you're coming from London, the rush starts about 3 o'clock, and usually somewhere along our stretch of motorway, things will grind to a halt, either north or southbound, or the ring road will grind to a halt. We had somebody come from Leeds to our last event. It took them 6 hours to get to site. And 3 hours of that was sitting behind an accident on the ring road, a mile from the site. So Friday night isn't the best time to come to us from that point of view, but it is if you've got to set up camping and you want to get early morning practice on the course. Otherwise, you've got to leave home about 5 o'clock, which people do. And we get people down from the West Country. We get a lot from London. We've got a big entry from Lee Valley this year, which, of course, is North London anyway. So that's relatively near. We get people from Doncaster way. We've had people from Scotland. Because we're near the end of the season, it benefits us in one way. The ranking lists, which determine who gets promoted at the end of season, are based on the best 5 results. So if somebody's got 5 results that wouldn't promote them, they're then looking for more competitions to do to get a better result and discard their worst ones. So we get a flurry of people who are desperately trying to get promoted or desperately trying to avoid getting demoted, which also works on the same basis. I think there's only 2 competitions after us this year. So geography and availability affect which one people can get to. Sometimes they do all of them. In Division 2, a lot of competitors will do maybe 12 or 15 competitions in a year. In Division 1, they do every competition, almost completely. The only thing that stops them is that most of the events have got an entry limit, and there's more paddlers than the competitions can take. The entry limit is based on how many hours of daylight have we got.
I'm assuming Division 1 is the top rated people.
No, there's Premier above that. Goes Prem to 4. We haven't got a Champions League yet. Don't think we will, actually. Premier is shrinking slightly. Participation numbers, well, in the early 2000s, participation numbers were dropping. 2012, the Olympic coverage, it started picking up again. And Lee Valley Canoe Club, which is based at the Olympic course, was set up then as a development centre. So they've been sort of promoting themselves in schools. They've been getting schools to do canoe slalom as their afternoon games option in some cases. So they have been pushing, pushing large numbers of people into slalom. That rush has died down a bit, but they're still a big club. The other big one is Home Pierpont, Nottingham, which is the course that was built in the 80s for the World Championships to be held, and has held 2 World Championships. So those 2 clubs at one stage were hammer and tongs against each other. We get a big entry from both. Not so many now, but it's still picking up. I don't know how many we got today. It was about 30 already on the online system when I checked a week ago. And a lot of those are from Lee Valley. So yeah, Canoe Slalom produces some mileage. Division 1, one of the main events is Grand Tully, which is in the Scottish Highlands. Then there's Treweren, which is North Wales. The D, which is Mid Wales. The artificial course in Middlesbrough. Doncaster. The artificial course at Cardiff. Quite a few other places. And people generally do all of them. I say a lot of people base themselves in Nottingham because it's a good centre for getting to those remote ones, and it's got the Nottingham course to train on. And the Nottingham course uses the natural flow of a river, so it doesn't cost anything to run the course. Lee Valley is pumped. 8 big pumps. I don't know what their electricity bill is. I know for our 2 pumps, which are smaller, it's 25 kilowatts. So it's about £40 an hour for the electricity. I think Lee Valley have probably got a better price and more efficient pumps. Built 20 years later. Pump technology's moved on. In fact, if anybody knows where there's a big pot of development money, we'd like to replace the pumps. Because ours are vertical pumps, so the water arrives at the top of the pump pipe with considerable velocity, which is then wasted in splashing around. The modern pumps are the Archimedes screw ones that you use on theme parks, and the water arrives at the top with almost 0 velocity. So you're not wasting energy in accelerating the water to a high speed and then letting it disperse that energy in a big wave. I reckon a third of our energy loss is in that excess velocity. But it was quite a big exercise to replace the pump chamber, which has got vertical pumps, with one with angled pumps. The Archimedes screws run at about a 30-degree angle. So they're long spirals with a drum round them that rotate about once a second. And the water just trickles out of the end, but in surprising quantities. We're pumping 2 tons a second up through 3 meters. Hence the 25 kilowatts per pump. And we're using 2 pumps. There are 3, but the third one's damaged, and it's only a backup anyway. If you run 3 pumps, the water flows out of the sides of the course, and the features get less usable. We call it washing out, because there's so much flow through them that the structure of the wave, this is what you use, disappears. Becomes like a flooded river instead of a natural river, if you can visualize the difference. But the nice thing about this course is that virtually everything in it is changeable, almost all the features. So I'm trying to screen share something different. Get there in a minute. So the concrete shape of this drop is fixed, but this lip here is produced by a fiberglass boulder, which is bolted to the riverbed. And all the way down, we've got these boulders or pipes or boxes and things bolted onto the riverbed, and they're all movable. So over a period of time, you can evolve what the course does. I say over a period of time, because we don't alter it very often, but over the last year, we've had damage to the boulders done because we raft on this course. A raft with 8 people on is a couple of tons. When that runs into a boulder, it's quite a strain, and we've lost 1 or 2 boulders because of it. And we had a big erosion problem down at the bottom of the course, and we had to remove a dam from there. So the course is now fairly different from what it was last year. And we're trying to reinstate some of it because it's not as good. But some bits have actually got better. So all the artificial courses use that sort of system. I say that the first course was Home Pier Pump, Nottingham. I learned a lot from that. The second one was Teesside. While Teesside was being built, they were designing Northampton. They got Teesside built, discovered some things they didn't like about it, altered the Northampton design. We were the third. There's now one in Cardiff as well. There's London, Lee Valley, the Olympic course. And there's one other, Pinxton, Glasgow. They built one. They were talking about building one in Exeter. But they haven't at the moment. I think it's too far from the centre of the country to have a big catchment. They might. I'm sure if they can find somebody to fund it, they'll build one. Because they've got a river with plenty of water coming down. And they've got enough drop on one of their big weirs to build it round the weir so that they don't need to pump it. Teesside wasn't pumped, but the bottom half of Teesside is tidal. So what they've done is put a barrage in below it, and they pump the water out of the course up into the high tide. So at high tide, they pump water out of the course, and at low tide, they let it flow out. So they pump it part of the time just to keep it constant, which is an interesting approach. I think Cardiff's entirely pumped. I'm not sure. I think Pinxton's pumped.
Well, that's all very interesting. Has anybody got any final questions before we wrap up? It's getting to Rick's bedtime, I've heard. So. Okay, with no further questions or comments, I would suggest everybody briefly unmute themselves and give Alan a quick round of applause. That would be lovely.
Thanks very much, Alan.
Well, thank you for staying the course. I hope it wasn't too... I didn't know what level to pitch it at, so I hope I got something to suit everybody. It may have been a bit too technical for some. It may have been a bit too slalom oriented for some, but I don't know. Nice one, Charles.
It's only been an interesting talk.
It has indeed.
Yeah.
Thank you. It certainly helped me with the software development. I've seen some bugs tonight. I saw some while I was playing with it.
Hey, here we go.
Presentation done, so I hope we don't see them on the day.
Oh well, good luck with it, and I shall bring the meeting to an end. Thank you very much, Alan, and we hope to see you in real life before too long.
I'll do my best to get to the next Wakefield show. I always do. Sometimes they clash with something, but I've got to a fair few of them. It's always the first one I aim to go to.
Excellent. Quite right too.
I can't get to that. It's London or West Country. They're all equidistant in terms of time. Anyway, I was to say good night. Thank you for your attention.
Thank you again.
Thank you.
Good night.
Okay. Good night, everybody.
Good night.
See you all again soon.
Good night. Will Rick's
Bye.
recording end? Will Rick's recording end, Will?
Oh, it will when I kill the meeting. Au revoir.
Au revoir.